Hey guys, Matt here today. Welcome back to another video. So I just woke up and I decided to make this video. So today I'm going to be doing a bunch of LeetCode problems. One of my friends sent me this, oh yeah, right here. One of my friends sent me this list of supposedly 75 really good LeetCode questions to do. So I thought it would be pretty fun to work through these on video. And yeah, so today we're going to be doing the array problems. And then it looks like they have a bunch of really good categories. So we'll probably do, I don't know, we'll jump around a bit. We'll see how I feel. But yeah, so this is going to be a little bit different from the usual videos because rather than me explaining a solution or a concept in depth, I'll just be working through these problems and explaining my thought process. So I have seen some of these before. Hopefully, there will be at least like a couple that I haven't seen. That way you'll get to see how I really think. But yeah, so I'm just gonna finish my breakfast and then I'll see y'all later. So, hey guys, Matt here. Just finished my breakfast and I think we're ready to start. So full disclaimer, I'm going to try and do these problems as quickly as I can. I actually have a timer here. But if you want me to go into the problems more in depth, then let me know in the comments and I can make a video where I do that. But let me put on this music, start the timer, and alright, let's go. So this first problem is two-sum. I actually have done this problem before. I actually got asked this in an interview, but basically you're looking for two numbers that add up to the target. And you need to return their indices. So the reason we use a hash map is because we can encode the array into a hash map, and then we can look up the elements we've previously seen in of one time. And then the reason we use a hash map and not a hash set is because we need we need the mapping value so that we know what index our number was at. So we're gonna loop through, and then we're gonna do int temp equals target minus nums I, and that's what we're looking for. Hashmap dot key set, I think. And then there's our solution. So we can just return God, I forgot the syntax. I think it's something like this. I hope that's right. And then otherwise we have to add our new element to the hash map. And that should be good. Let me just return this here. Oh God, alright. Alright, so we passed the test case. Hopefully we can pass the submission. Alright, nice. So we did pass the submission, and it was pretty fast, pretty memory efficient. I don't think you can do better than O of n. Maybe you can make a few optimizations there, but I'm pretty happy with this solution. Alright, best time to buy and sell stock. So feel free to pause the video and read and think about the problem. I actually encourage that. Or I would encourage that. Let me turn this down a little. Maximum profit, so you cannot sell the stock before you buy. No shit. Buy on day 2. Okay, so it looks like we're looking for the greatest pair, or the pair of numbers with the greatest difference, such that the larger number comes later. Okay, so I think, so this solution, if you just look at every single pair, that's the brute force solution, and that would be O of n squared, because you have n choose 2 pairs, and that's actually precisely this many pairs. But we can definitely do this in one pass. I think the trick here is to keep track of the lowest price seen so far. So int min so far. Oh, actually, let's just do a before, yeah, int min so far equals price is 0. And then let's do this in case, because I think LeetCode likes to give you stupid things. Then we'll return 0. That way we don't get a array out of bounds exception, index out of bounds exception. Int min so far equals price is I, and then int max profit equals 0, and then 4, and then we just iterate through. And starting at 1. And then it doesn't matter where you put the min check, but I'll just put it first. If price is I less than min so far, then min so far equals price is I. And then we'll do the profit check. And you don't have to store indices here, so you don't need like a hash map or something like that. Or not a hash map, you wouldn't need extra variables. And then max profit equals. And then we just return max profit. I think this should be good. So in an actual interview, I would look over my code to double check that it's good. Oh god, is the timer not running? I mean, it was running, but I'm not sure if it showed up on the video. But okay, this is Ovan. I'm sure there are some random optimizations, but I can't imagine an interviewer would be upset with this. Next, contains duplicate. Okay. Find if the array contains any duplicates. Okay, this is very similar to tsum, except we don't need any indices, so we can just use a hash map. Or hash set, sorry. Then if hash set dot contains nums I, then we'll return true. And then if we exit this loop, we'll return false. And we still have to add to the hash set, so I think it's add. I'm not 100% sure. Hopefully that works. Okay, this looks good. This seems like an easier version of the twosum problem. Oh, oops. Okay, let's submit. Oh god, why is it so slow? I mean, this is Ovan time. So I feel like the runtime thing isn't really that accurate, because you can just make a few optimizations that would increase the speed. This is Ovan time, which is optimal complexity, and it's not like we're doing unnecessary operations. But maybe I think this is just how hash sets work. So I think if you try adding and it already exists, it'll return false. So then this might be a slight optimization. But it really doesn't, like in an interview, I doubt they would care if you did it like this or with the if contains. Okay, yeah, that's actually pretty dumb. Now we be 82%. I mean, it's just a small thing with how hash set in Java works. Alright. Product of array except self. Okay, it looks like we're getting into the mediums. I wonder if they'll put any hard problems on this list. But yeah. Okay, seems pretty easy. So and we can have an output array, so int and then let's just compute the product first. Oh. Oh, actually, it says without using division. Okay, I didn't even, I didn't even see that. My bad. But so what I was originally going to do is just calculate the product of all the numbers and then go through each index and divide by the value at the current index. But then I was thinking, oh shit, what if the index is 0? But actually, we have another issue. It actually tells you without division. Oh, and follow up, can you solve it with constant space complexity? Okay, hmm. Okay. Oh, okay. I think the trick here is to compute this number, you compute these three, right? To compute this number, you compute this one and these two. And then for 8, it's just these two and this one. So really, you're just multiplying the numbers on both sides of the array. So, okay. And I think I know how to do it without, um, without extra space. So what we're gonna do is, let's just let's just do a check. Return, I don't even know what we would return, but, maybe 1, I guess. But, okay. So we're gonna iterate through. Actually, we're gonna, okay. Solution 0 equal 1. So we're going to iterate through, and then first we're gonna build up the left products. So the product at solution I is going to be every number from 1 to nums I minus 1. So to do this, all we have to do is solution I equals solution I minus 1 times nums I minus 1, I believe. Yeah, that's right, that's right. So yeah, we're basically taking the previous, so right here, say I equals 3. Then to compute 8, we're taking the product of all numbers to the left of 2, which is 1, and then we're multiplying by 2. And then, okay, sorry, that I shouldn't have said that because we also need to do the right products. But basically, if you look at this code hard enough, you should be able to get it. And then now we have all the left products in place, and now we need to do the right products. I mean, we could use nums for the right products and change the values of nums, I believe. Or hopefully they don't care. I don't think this would count as extra space complexity, but so we're just gonna do this. Wait, what? Okay. So I need to check the indexing, but this is the general idea here. And we don't need to care about the very last one. There's nothing to the right, so the left products is the answer for that. Right product. Sorry, this should be oh my god, what am I doing here? I was trying to build the array, but really we're just doing this. So then we could actually have this at 1. And then this would equal nums I. Yeah, I think this would be right. So then the very last case would be I equals 0. Then we have solution I minus 1 times, or solution I times the right product. Alright, honestly, if this were an interview, I would make sure this code works, but we're just going to debug by running the test case. I mean, you can do this in a hacker rank. Oh god. Okay. So if that worked, it probably should work. Alright, nice. Oh wow, faster than 100%. But the memory is pretty bad, but we didn't use any extra memory, so I'm not sure how LeetCode calculates that. Alright, that was actually kind of tough. Now let's do maximum product. Oh wait, we didn't do maximum subarray. Oh, okay, I've actually seen this problem before. It was actually on a test in an algorithms class, but the basic idea is you're going to keep a cum sum, or a running sum, of numbers, and then every time you encounter a new number, you're going to see if adding that number to your current running total will increase your current running total, or, sorry, I explained that really badly. So what we're going to do is every time we encounter a new number, if that number is greater than our current total plus that number, then we're just going to restart our running total. Otherwise, we'll add it to our running total and we'll keep going. So, yeah, sorry for that explanation, but so we're going to have int temp sum equals, God, I don't even know, equals 0? Oh, but you could have negative. Oh, what if everything's negative? Actually, no, it doesn't even matter. So, or if it really becomes an issue, we could just set these to integer dot min value. So we're gonna do temp sum equals math. Oh, it does matter. Okay. I think this is how it works. Actually, you know what we could do? Yeah, I should have just done this in the beginning. And then we'll just do an array check here. Alright, so we'll start at 1 then, and then we'll do temp sum equals math.max temp sum plus what's currently there. Or if what's currently there is greater than our temp sum, then we'll reset it. Yeah, like say our temp sum is negative, then we'll reset it. Yeah, that would work. And then max sum equals math.max temp sum max sum. And hopefully this works, man. Oh, but what if I'm forgetting the first case? Actually, no, then this wouldn't even run. We're good. Alright, let's submit. Alright, nice. That was pretty good. Now next is maximum product subarray. I can guess where this is going. Find the contiguous subarray. How much time do we have? Oh god, wow, it's already been 18 minutes. Shit. Um, find the contiguous subarray with an array which has the largest product. Okay, it sounds like the same thing as the previous one, except with products you have to care about negative numbers. So I think we'll have 2. Oh, okay, I got it. Oh. Not only did I use the wrong index, but I typed some. And then as usual, we'll have this check because LeetCode fucking hates us. and then, okay, and then we'll iterate through. So what they want you to figure out is that, I'm guessing they want you to check if the number is negative, and then if it's negative, you need to use the min product to calculate the max product, potential max product, and if it's positive, you need to use the max product to calculate the potential max product, but we're lazy, so sorry, max product to calculate the potential min product, and min product to calculate the max product, because a negative number basically does the flippy. But we are lazy, so we're just going to do int temp1 equals, so this can be the min, thumbs I. Actually, I don't even see why. Oh, if it's 0. Oh shit. Oh wait, no, we're good. Oh, okay, so we're gonna do yeah. So this implicitly checks for negative. So this temp1 will be our new min. Yeah, I'm just thinking about the 0 case. Let me turn off this music. At least put it very low. Yeah, okay. Whatever. Okay. Alright, I see how we do this now. Alright. So this is our real answer. And then, yeah. There we go. Hopefully this works. And then I will be very sad if this does not work. Alright, let's see it. God, I've never been so No! So we'll just run through this. Oh God. Alright. I am so tired right now. I'm sorry, guys. Let's see. If we run through this, not that min. Wait, I don't understand why this would not work. It should be 6. Yeah, so first we set it to 2, then we get temp2 equals math.max, and that's going to give us 3 times 2 equals 6, and then our max is going to be math.max 6 versus the new number, which is 3, and then solution equals 6. What? Alright. Six, negative 2, 4. Why would it change? Why would I output? Oh my god, I'm so dumb, guys. Ah. Alright, I'm sorry. That was kind of embarrassing. Not gonna lie. Yeah. Yikes. Yikes. God, I feel like, okay. Oh wow, it is so slow. What the hell? Um, why is it so slow? It's, how do I move this down? It's still O of N. Maybe it's all the max calculations. Oh, maybe it's printing. Hopefully. Okay, alright, it was the printing. So we're good. Oh, then time, best you can do. And oh god, it's oh god. Alright, I need to think smarter. Find the minimum element. Okay. Uh, if you have anything sorted, it's definitely going to be like binary search-esque. So, okay. And the unique part, so we're looking for the minimum. If we compare two elements, oh, okay, I see. So the idea is that your high you want to get your low into, and you want to find the sorted part, or the lower sorted part. So while low less than high, we guess. And then if the guess is greater than the right, it means we're not yet in the sorted part. So then we'll update our low. Else our guess is less than the right. Oh, then we are in the sorted part, and we can update our right. And I really hope this works. And then once low and high, oh, okay, low will always be incremented to high. That's the breaking condition. Or low equals high. Oh god. I'm just gonna hope this works. I think this is it. Oh, we actually need to return the value, so. Oh wow, I switched between using low and high and left and right for some reason. Okay, please work, please work, please work! Oh, okay, thank God. Alright, this works. Yeah. Find, search, and rotated sorted array. Wait, this is just... Okay, I'm just gonna steal my code from here. This sounds like basic, just binary search. So, the trick here is because it's rotated, we need to use our minimum element as an offset. So, int min element equals low. Int offset, we'll say, equals low. And then we know this code works from the previous problem, but now we just do binary search. Oh god, I hope this works. Int guess equals low plus high divided by 2. And then we just add the offset after that. And then if... Oh, actually we need... Okay, never mind. Because we need just low and high, we need two variables, I think. Int real guess. That's a good variable name. Guess plus offset. And then if nums real guess. Oh, another problem is you have to return -1 if it's not found. So we're not guaranteed that it'll be found. But hopefully this will work if nums real guess. So this is binary search. If it's less than target, low equals high plus 1. Or sorry, low equals guess plus 1. Else, if it's greater than the target, then high equals guess. If it's greater than the target. Yeah. Well, this is greater than or equal to, so. And then actually, just to be safe, let's do this. And you need to return the index. Return we'll return real guess. And I forgot to mod here. we need to mod by the size of the array to wrap around. And if we break this, we'll return -1. Alright, please work. Oh no. I wonder if that's just a problem with our yeah, I think that's just a problem with this, because low less than high will immediately break if it's a one index thing, and then we return -1. So oh god. Actually, we can just do this. Alright. An error has occurred. Oh my god, this is what I was talking about earlier with LeetCode, man. They love throwing in these empty arrays into your problems. How is this still wrong, man? There we go. Guys, I think I might be brain dead. Oh my god, how did I not... Okay, this should work. Because we're doing guess +1 first. Okay, there we go. Yeah. Yeah, so we're doing guess +1 first. That's why we need high equals guess -1 afterwards. Okay, well that didn't go too well. So the speed is good, which I'm happy about. The memory is not so good. I think there's definitely a way to calculate, to do binary search without calculating the offset from the very beginning. But I am too dumb for that, so I'm gonna say we pass this one. I'll probably come back to it later. Maybe make a video on it. Alright, threesome. Are there two? Okay, this is like twosome, but more advanced. So, first off, the best sorting. Did I dislike this? What the fuck? Okay, so the first thing is, so twosome is O(n). Threesome has to O of n squared because you're looking at an additional number in the list. So because it's O of n squared and the best sorting algorithms are n log n, we should just do a sort. So I think this works. I'm not 100% sure. If this sort doesn't work, I'll just like look it up. I don't know. But oh, can't contain duplicate triplets. Okay. So we need them to add up to 0. So we're basically just looking for this in the remaining part of the array. So left equals I plus 1, right equals nums.length minus 1. So this is the advantage of, this is a classic, like, I don't know what they call it, maybe like bidirectional sweep. So the idea is you have two pointers on the left and right, and then you just move them closer and closer to each other, and your stopping case is when they cross, or when they meet. So the idea is if nums left plus nums right. So if you remember, we sorted the array. So left is always going to be lower numbers, and the right is higher numbers. So if nums left plus nums right is greater than what we're looking for, then we need to decrement right. Otherwise, we'll increment left. And actually, we need to we need the stopping case as well. So I forgot an if statement. There we go. Now we're good. Then we can add this to our solution. So we'll do I don't know, array list in probably link. Yeah, array list is fine for this. because our solutions aren't very big. And then we'll just add. Oh god, what am I doing? So we need to add the left number. Oh, okay. We need to add, so since it's sorted, we need to add, the target is lowest. And then we'll add, dude, what am I typing, man? This should be nums I. And now we're good. And then, yeah, this should be good. And then we need to add this to our main solution. So we can just have an array list. Actually, if we have a lot of solutions, the linked list is probably better. Response. I see all the pro people call their return arrays response. Okay, and then res.add solution, and then return res. Error expected. Okay. Oops. So yeah, a few errors. Oh my god, why did I use low and high here, man? I'm so sad. A few errors. I don't think they would care in an interview. Oh god, time limit exceeded. What the fuck? Well, left, right, less than right. What? Oh. So we'll be stuck on this if statement. Because we don't really increment, so we just need to do an increment. And now that I think about it, we also need to do a check. So while left less than right. If nums left, then oh, actually. So yeah, they said no duplicates, and by doing this, we basically go past all the duplicates. Alright, and then we decrement one more time. Hopefully this works. I will be very sad if it doesn't. Output expected. How did I go through? I thought we would have gotten rid of duplicates. Oh my. Okay, we also need duplicates here. To check for duplicates here. Oh god, am I blocking this? I'm so sorry. I just realized that's probably what I'm doing. While left. So right here, to check for duplicates, we're going to do while nums I equals nums I plus 1. We'll increment I. Minus 2. Right. Yeah. Yeah, this should work. So again, same concept. We're going past the duplicates by incrementing I while we know the next number is the same. Okay, this worked. I think I'm not sure if array list or linked list are the best ones to use in this situation. Linked list has O of 1 add, and for small solutions, array list has O of 1 add. I wonder if there's a more clever solution, but this is O of n. I can't imagine any interviewer would not be happy with this. Okay. How much time do we have? Oh god, we almost used up. Oh wow, I really slowed down. I think I'm just getting like really tired from doing so many problems, but looks like we're on the final problem. So, okay. Given where each represents. Container and n is at least 2. Okay. Alright, this sounds like another bi-directional sweep type problem. I'm so sorry if I blocked the last one. So basically we're looking for area. So area is going to be the indices, the difference between the indices times times the height times math.max. Oh, times the lower one actually. Sorry. Yeah. So let's just int max area equals 0. Well, left less than right. So we can compute the area first. So this is going to be right minus left times. So yeah, this is, wow, I like this problem. This is like combining our running total type problem. Actually, no, it's not. Yeah, no, never mind, it's not. But it's combining our bi-directional sweep with this concept of checking against your current max. Yeah. And the reason we take the lower height is because that is how water works. Like, see right here, it's the lower height that limits you. So that's also going to be the concept behind our incrementation. Am I missing it? Oh god. Oh. Here we go. So yeah, we're going to do if left is... Oh, okay, yeah. So if height left less than height right, then we're going to increment left. Because we're really just looking for the higher height. And this should be good. So yeah, the idea behind this statement is we're just looking, and then we always want the tallest possible, like, what are these called? Tallest possible vertical lines to compute our area, because taller lines equals higher area. So we're always going to, and since we're starting from the left and right, we're not going to miss a single vertical line, and that's why this solution works. Return max area. Alright, please work. Please. I'm actually kind of tired. I don't think I've ever done this many problems in a row. Alright, if that worked, this should work, unless they have like negative heights. Okay, nice. We actually ended on a good note. Pretty good solution. Oh man. Whew. Okay, how much time do we have? Okay, so, oh god, oh god. Was that like, what, 13? 13 minutes? So 45 minutes for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 problems. That's not terrible, but considering the fact that these are like LeetCode easy / medium problems, and that I've done some of these before, I think I could have done that faster. Hey guys, yeah, I just wanted to record a reflection on this fun activity. So yeah, I think this list is actually pretty good. The array problems, I liked how they started with easier concepts, then they got slightly more difficult, and it definitely covers a wide range of the type of strategies that you'll see when doing array problems. So first, so I'm just going to talk about the different array problems I've seen. So for easy / medium problems, they're always going to fall into a few categories. One is the hash map type problem. So for example, like twosum is a hash map type problem, and a lot of companies like to do modified twosum problems on their HackerRanks. But basically, hash map is when you want to have fast lookup on previous elements you've always seen. Usually, if you're looking for two numbers that add up to something, or two numbers that fit a certain criteria, or duplicate type things, then you want to use a hash map. And then another strategy is the bidirectional sweep. This is where if you have anything sorted or even not sorted, it can be applied to a lot of sorted problems and also not sorted problems. It's where you just have a left pointer and a right pointer, and then they slowly meet each other, and you keep updating whatever it is you're looking for. It could be a sum, and you keep looking for the highest sum, or something like that. And then we also have problems on sorted arrays. For example, these two were the trickiest for me, just visualizing it. Actually, was that one the trickiest? I can't remember. But sorted problems, usually they want you to implement some sort of binary search to take advantage of the sorted attribute. And then another strategy would be keeping a running total. So that would be in these two problems and also this one, I guess. So running total is where in order to find a maximum or minimum, you can save time by keeping a running total of the current max that you've seen so far or the current min so far. And then finally, we also have, which one was it? Oh, threesome. So there are also times where if you're given a more complex problem or you're looking for more elements, then and you can't do it in OVAN time, then you should do a sort, because sorting is bad for problems that can be done in linear time because of the fact that sorting takes longer than linear time. But for other problems, sorting is n log n, if you're using like merge sort, in which case you can do a sort and it'll make your problem a lot easier, and it also won't be detrimental to the runtime of your algorithm. So overall, I think this is a pretty good list. I enjoyed doing this, although I was getting pretty tired at the end. And yeah, so that was pretty fun. Next time we'll be doing DP probably, or graphs. I haven't figured out yet. But thank you for watching, and if you want to see more videos, I would really appreciate a like and a subscribe. So hopefully next time will go better, and thank you.